I'm gonna turn. All right, so correlation, so that was part of what we described when we talked about our scatter plots. And what it's looking for is the direction and strength of linear relationships between two quantitative variables. We don't typically graph categorical, but we will talk about that a little bit in this unit, how you might be able to do that. So if you have a linear relationship, the points are going to be close to a straight line, correlation is strong. If the points are widely scattered, then we say the correlation is weak. And we use R for correlation. So what is correlation? Well, R is measuring our correlation. If we have a positive slope, we'll have a positive association, a positive R. A negative R doesn't mean something bad, it just means something has a negative slope. So we kind of have this continuum. So we have like 0 in the middle. That means there's absolutely no correlation. The points are just widely scattered. And then we have a strong negative, which means a perfect line with a negative slope would be a -1. A perfect line with a positive slope would be a +1. And then we have along the continuum, we start using words like moderately strong and very weak and slightly. So we're going to add in all those other words we've already kind of talked about a little bit. Let me just go back here and say for a minute that when we talk about R, it only measures the strength of a linear relationship, not curved relationships. All right, so here's some different R values and what their data looks like. Here, this first one you see is kind of just all over the place. This one you can kind of see kind of the negative trend, but it's pretty spread out. This one we kind of see the positive trend, but again, it's spread out. Then we get closer together and closer together and almost perfect here. So just some pictures of the different correlation. Your job is to work through this task by going to this website here at the top. So digital first, so you're going to go there and you're going to follow these instructions and then you're going to answer the questions that you see here. It's going to help you kind of figure out what correlation is and what changes it, what affects it. Calculating correlation. Well, oftentimes we'll eyeball it, but the graph is sometimes misleading because if we zoom in to the data, it looks like the one on the left. So this is something that's zoomed in. Notice like our axis starts at 60 and 40. But over here on the right, we start at 0 and 0. So the same data looks like super close together, whereas on the left, it looks spread out some. So sometimes it's really hard to just eyeball it because you can't tell based on the scale of the data. So, of course, we have a formula. So the formula, we have y divided by n. Then we're going to find the sum of all the products of every x value minus x bar divided by standard deviation of x. Then y minus y bar divided by standard deviation of y. We'll do a little bit more of that on Tuesday together. Right. Here's a full example, kind of goes through the correlation here for this SEC football. Talks about R in context, which will be really important. We do everything in context here. So you see you have a pretty strong correlation, which is positive 0.936. So what we say, correlation of 0.936 confirms what we see in the scatter plot. There's a strong positive linear relationship between points per game and wins per SEC, wins in the SEC. So we want the context. We want to describe it using direction, form, and strength. So your job is to summarize what you've seen in these as well as answer those questions and practice that correlation.